This is section 515. We're going to be creating a polynomial from a graph. And so today's objective, we're going to look at a graph and be able to create a polynomial. Now, all polynomials, when factored, can be expressed in this form. Some leading term or leading coefficient times, and then we can write it as x minus my 0. So this is x minus my 0, and it's my first one. That's why I use this 1. This is x minus my second 0. This is x minus my third 0, etc., etc. It's basically, if we know what the zeros are, we can work backwards to be able to create our polynomial. Now, a few things to consider. How do we find this a? What we do is we plug in a point for x and y to solve. So usually there's a point on the graph that we can choose to plug it back in. And then does multiplicity affect the graph? Yes. Remember, if at the 0 it crosses, we express an odd multiplicity, we just say it's to the first power. And if it bounces, we say it's to the second power, which is going to be even. So here's our first one here. So my zeros are going to be -3, 0, and 2. So that's where it crosses. -3, 0, and 2. So I can write it as y equals a times x minus my 0, x minus my 0, x minus my 0. So it's always x minus whatever your 0 is. Now you can kind of simplify it a little bit. X minus 0 is just x, and then x minus 2. So now we got to look at this graph, look for a point on the graph, and we're going to use that. Now the point can't be a 0, but it can be anywhere else. For example, I can use this point right here, which is -2, 8, or I can use this point right here, which is 1, 4, or -4. Now it doesn't matter which one you use, you're going to get the same value for both of them. So it looks like 1, -4 is a little easier, so I'm going to use that one. So you plug in 1 for x, you plug in -4 for y. Now why am I doing this? Well, if I plug in my values for x and y, if you look at it, a is by itself. There's only a variable. There's only one variable. It's a. That's what we're trying to find. So if you find a, then I can express it as my polynomial. So we just need to clean this up. So times 4 times 1 times -1. So -4 equals 4 times -1, so -4a. Divide both sides, a equals 1. So now that I know a equals 1, we look at our polynomial before we plugged in a, and I plug in 1 for it. So my answer is y equals, and I'm just going to switch the x. So 1 times x, which is just x, and that's my answer. So to go over the steps again, the first thing that we do is we need to establish our polynomial. So it's y equals a times x minus your 0, x minus your 0, x minus your 0 for as many zeros as you have. Now, because each of these crossed, that's why my multiplicity was all to the first power, right? I didn't write second power or anything like that because they all crossed. And then I could go through and I can find a. And to do that, you find a point on your graph that's not a 0, and you plug it in. I found 2, 8, and 1, -2, 8, and 1, -4. Plugged them in. You can find a. Let's look at another one. So my zeros are these values. So y equals a times x minus my 0, x minus my 0, and then x minus my 0. Now I need to look at a graph on the graph, like a point that I can pick. It looks like this point right here, that's going to be 1, 5. The multiplicity, it's crossing, 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 and so there we go. I have everything that I need. So now I need to find my a. So plug in 5 for y, and 1 for x. So I get 5 equals a times 4 times 1 times -1. So that's negative 4 again. Divide both sides by negative 4. There's my a. Oh. So now I just need to plug that in, that original equation. So y equals negative 4 over 5. Now x minus 0 is x times x plus 3 times x minus 2. There's my polynomial. I want you to practice this one, but I want you to be very careful with this 0 here. If you think about the multiplicity of what the multiplicity needs there. So go ahead and pause it, and then you can check your answer. So what did we learn today? We learned how to create a polynomial from a graph. Now, to start creating it, the first thing we need to do is we need to write out a generic polynomial. Y times x minus my 0 times x minus my next 0, x minus my next 0. And then we have to make sure the multiplicity is taken care of. So we have to look at the exponent, right? If it's even, we have to make that a square. And then you plug in a point for x and y and solve for a, and then rewrite with a. This does conclude our lesson. If you have any other questions, please leave them in the comments.